for 2, slope and direct variation. And what this really means, if something is directly related, like this will be in red, so don't write this. The hours that you work, if I work 0 hours, 1 hour, 2 hours, let's say if I work 0 hours, well, I should probably get no money. But then if I work 1 hour, I got 10. 2 hours, I got 20. I think we can see that y would be directly related to x. And all I would have to do is basically take x and multiply it by 10. And that would give me y. But there's nothing being added. There's nothing strange happening. There's no division with a variable. So as we make this stand out, let's rewrite this y equals kx somewhere where you have space. And let's tag these different things. K is the constant of variation. The words tell us that it cannot be equal to 0. And really variation is just how it varies. So if it was 10, then I'd do 10 times 0, or 10 times 1, or 10 times 2, and increase from there. So a direct variation is described by equations in this form, y equals kx, where k cannot equal 0. The equation y equals kx represents a constant rate of change, so it's not like you're going to have the values go from 2 to 4 to 8 to 16, 32, and so on, because those would not be constant changes. That would be like doubling every time. And so k is the constant of variation. The first type of problem you'll be asked to do is to name the constant of variation for these different points. And you're also going to be told to find the slope. And it might seem like a bit of a silly thing. So let's picture these 2 points that they give us here. And let's draw a vertical line down as dashed. Mine's dotted, but you can make yours dashed. And then a horizontal line over. And we know that that little mark there means this would be a 90-degree angle. So I have to form a right triangle. So I'm stepping over and I'm stepping up. And it looks to me like this goes up 3 as it goes over 1. So that if I had a formula, I would know that I'd have to take that value of x and multiply it by 3 to get my y. So when they tell us to name the constant of variation, well, we have to call that out by saying k equals 3 and then box it. And since they asked for the slope, well, the slope is the exact same thing. It's the number in front of the variable. So m is 3, k is 3. The other thing, too, is we labeled this line. Here it is right there. All you got to do is pull it off. So I'm making you do a little bit more work than they ask you to do on these. Same deal over here, but now let's just jump right in. Here's negative 2. Well, the constant of variation is going to be negative 2, while the slope would be negative 2. And if that seems kind of simple and straightforward, that's great. Let's make this a little bit more challenging by showing the triangle. That helps us see that we are stepping 2 steps down between points. So I will write negative 2 to the side of that vertical line on that triangle. And then we can see that it steps over 1. And also pay attention to the fact that these values increase just by 1 every time. If they doubled or did something different, we'd have to make sure we did a little bit more math. So it's down 2 for every 1 that it goes over. And having done it either way, both of them agree with our work. Name the constant of variation for y equals 1/4 x. Then determine the slope of the line that passes through 0, 0, and 4, 1. Well, it's all for the same problem. So if you figured this out already, well, you were like, well, it's just a number in front of the variable. So I'm going to write k equals 1/4. And I also know the slope would be the same thing. Let's do some additional work, though. Because we remember the last section, don't we? If I know that the slope formula is rise over run, or I can also call it the delta y over the delta x, or the change in y over the change in x, I can rewrite the formula, even though it's getting to be a little bit routine, perhaps, where I say y sub 2 minus y sub 1 is over x sub 2 minus x sub 1, and then I'll plug in my y values. I think of that as y2. I think of that as y1. So I'll write 1 minus 0 over, well, I think of this as x2 and that as x1, over 4 minus 0. And when I simplify that out, it agrees with my constant of variation, and it agrees with the slope that we knew was just in front of the variable. Graph each equation. Well, here's what's unique about all of these different problems. They always go through the origin. The one that we did in 1a went through the origin. The one that we did in 1b also went through the origin. And the reason for that is that we don't have any additional thing being added to either of these formulas. And what that means is that if I plug in a 0 for x, 3 times 0 gives me 0. So I always know that these go through 0, 0. So go ahead and plot a point at 0, 0. Now let's do this just by choosing values. I know I could plug in a value of 1 for x, and that would give me a point at 1, 4, because 1 times 4 gives me 4. So here I am putting my second value here. But here's the deal. You would also know that this goes up 4 over 1, so the constant rate of change goes up 1, 2, 3, 4, and then it goes over 1. So if I wanted to count that way, I have to make sure I count accurately, and there gives me 1, 4. So I talked about it both ways. I'm going to draw this line quickly, but you should be getting a ruler out. I cannot do a ruler smoothly on my iPad. I've seen better. I've also seen worse. And sometimes you'll see y equals 4x, or whatever the equation is for the line written to the side of it, to where it neatly and accurately describes that. You know, like if I had two lines so close to each other, I'd have to be more clear. Okay, now looking at number 2, let's go ahead and make this an on-your-own problem. I'll show the answer in about 5 seconds. There's the answer. We were told to graph it. We didn't have to say what the constant of variation was. If we did, we just say it's negative 1/3. And so when I think about that being rise over run, it's like I go down 1, but then over 3. So there's my triangle if I wanted to think of it like that. And again, I could also think of values. 0, 0, we know it goes to the origin. And then once I plugged in 1 over here, I'd get like a fraction. So maybe I try to plug in a value that it will cancel with my fraction, like 3. And so 3 over 3 becomes 1 times a negative makes it negative 1, which works down here. A couple more. Make these both on your own as well. I'll put the answers to both of these after 5 seconds, so make sure you complete the work and then check them. Okay, I have y equals 6x graphed. It's like it goes up 6 over 1. I have y equals 2/3. It's like it goes up 2 over 3. And again, a friendly reminder, they both go through the origin. If yours is at all different from mine, make sure you figure out the mistake you make and figure out why it's wrong. Oh, here's some more numbers. Same deal. 5 seconds, I'll put the answers up. Make any changes that you feel are necessary. I feel like I'm getting a little bit of a broken record here. Down 5 over 1, and then down 3 over 4. Let's check these previous 6 ones we've done. Okay. Do I have a positive or negative value here? I have a positive. So as I go left to right, my line is increasing. I have a negative. My line is decreasing. I have a positive, increasing, positive, increasing, negative, decreasing, negative. Oh, you know what? If you have this shown that way, it should have read like this. Y equals negative 3/4. If that threw you off, sorry, I'm just catching that now. I have a negative value. It's decreasing. So here's the deal. You should look at these and realize, well, okay, positive or negative slope, that is definitely a good way to check my work. You know, because it's that additional 1 point that you might get out of 2. just by being thorough. If you make a mistake, maybe you went up and over. So that double check is a good thing as a math student to do. Let's summarize this. The concept summary says that in direct variation equations and graphs, they're in this form, y equals kx, and again, k cannot be equal to 0. Otherwise, if it was 0, you just have a horizontal line on the x-axis. It always passes through the origin, so you can underline this, star this. I'm doing this all in red, you don't have to. And y varies inversely as x, but here's the deal. We're going to talk about that in later chapters, so just put a little arrow here, and just put not direct. You'll notice that you would have to actually divide by x if you wanted to have that, and that's making it something different. The slope is positive if k is greater than 0. The slope is negative if k is less than 0. So it kind of summarizes our thoughts in that video. We'll save the next types of problems for the next video, but this will mark the end of one of 2 videos for Section 4.2, Slope and Direct Variation.